This is a two-step question. You first have to find um, the constant for decay, and then you have to use that to figure out how long it would get to be 80% of that amount. Now, in the book, they do have a formula that says something like ln 2 over time is equal to k, something like that. You can use this formula only if you're looking for double time. So how long does it take for something to double? You could use that formula to find what k is. But in this question, it's a half-life question, so you can't use that formula. I guess you could use ln of a half, but what I like to do, though, is just use the regular formula. So the amount after a specific time is equal to how much you start with, e to the kt. Okay, and then they say it has a half-life. So that means that it goes from one amount to half of that in 1450 years. So I don't know what it would start with, but it doesn't really matter. Let's start it at 10. So e to the k times, it'll take 1450 years to go from 10 to half of that amount, which is 5. Okay, and then I'll solve this equation. I'll first divide both sides by 10. So I'll get 5 divided 10, which is a half, is equal to e to the k times 1450. And then change it to log form. So log base e of 1/2 is equal to k times 1450. So k is equal to the ln of a half divided by 1450. Okay, let's pull out our calculator to figure that out. Okay, it was ln of a half. Where's my ln? Ln of 0.5 divided by 1450. There we go. Okay, so our k value is, oops. So our k value is negative 0.000478. I'll throw a couple numbers in there. So that's what my k value is. So now I can use that k value and use the same formula to figure out the next part. Let me just go down, put this off to the side here. So the next part will be how many years will be required for this given amount of isotope to decay to 80% of that amount. Okay, so same formula, P of t is equal to how much you start with, e to the k times t. So this time they say how much to decay to 80% of that amount. So I'm going to start with 100%, and I'm decaying to 80%. Now, that's a little bit confusing because sometimes we'll put a 20 here, right, instead of an 80. So if they say they lose 80%, then you would start at 100, and if you lose 80, you'd wind up at 20. But in this case here, they just say that they decay to 80%. So you're starting at 100, and you decay to 80. So you start at 100 and wind up at 80. Okay, same thing, divide both sides by 100, so I get 0.8 is equal to e to the negative 0.000478 times t. Change to log form, so log base e of 0.8 is equal to negative 0.000478 times t. Divide both sides by that, so you get the ln of 0.8 divided by negative 0.000478. Okay, so let's bring decimals in again. And I've got ln, where's my ln, of 0.8 bracket divided by negative 0.000478 0.00478. Do I need any more numbers? I think that should be pretty good. So it's 466.8, call it 467. So my time then would be 467 years old. That's how old that one thing would be. All right, I'm not sure where that negative came from. Oh, that was part of the equal sign. Equals. So time is 467. Hopefully that helps you with that question. Love that question.